In simplifying an electric circuit, if impedances are connected in the form of a delta or if they are connected in the form of a star, and to simplify them, in many cases we need to convert a delta network to a star network or a star network to a delta network so that we can reduce and simplify the electric circuit. So in this video segment we shall see how we can convert a star network to a delta network and vice versa. Now let us assume that we have three impedances. So I have impedance ZA, ZB and ZC. So this forms a delta network. So essentially here these two are connected at a common point. So we find that we can represent them like this. So this forms a delta network. Impedances ZA, ZB and ZC. So now if I need to convert a delta network to a star network, then I would have three resistances. Let me name them as Z1 and here Z2 and Z3. Right? So I have impedances Z1, Z2 and Z3 and we have ZA, ZB and ZC. So now how do we convert a star network to a delta network? So I will not be going through the derivation of conversion of a star to delta. So let us write the final expression directly. So given Z1, Z2, Z3, if I need to find ZA, ZB and ZC, so how do we find ZA? Right? So ZA is the impedance here. To convert a star to delta, what we need to do is the numerator remains constant for all the three cases. Right? So what is the numerator? The numerator would be Z1, Z2 plus Z2, Z3 plus Z3, ZA. It would be Z1, Z2 plus Z2, Z3 plus Z3, Z1. And then the impedance which is directly opposite to ZA. So when I want to convert a delta to a star, right? So I draw a star network and I find that the impedance Z3 is just facing the impedance ZA. So therefore I divide this by Z3. Right? So similarly, what is ZB? So ZB is going to be summation Z1, Z2, which is nothing but Z1, Z2 plus Z2, Z3 plus Z3, Z1 divided by the impedance which is just opposite to ZB, which is Z2. And then we have ZC is going to be again summation Z1, Z2. So the impedance opposite to ZC would be Z1. So using these three expressions, I can convert any star network to a delta network. So now if a delta network is given, how do we convert that to a star network? So how do I calculate Z1? Now, for a delta to a star conversion, we find that the denominator remains constant, right? So what is the denominator? The denominator is the sum of all the impedances present in the delta network, which is ZA plus ZB plus ZC. Now what about the numerator? I need to find Z1. Okay, so on either side of Z1 I have ZA and ZB. Multiply those two. So Z1 is ZA into ZB divided by the sum of these three resistances. So similarly I have Z2. So on either side of Z2 I have ZA and ZC divided by the sum A plus B plus C. And what about Z3? So I have Z3 equal to, so on either sides I have ZB and ZC, so multiply them divided by sum, right? So we have the expressions for star to delta transformation and delta to star transformation. So let's take one or two examples and we shall see how converting a star to delta or a delta to star will actually help us, aid us to simplify the electric circuits. So given the circuit here, we need to convert and simplify this circuit so that we can find the equivalent resistance between the two terminals A and B. Right? Now if you observe here, there are two delta networks, 1 and 2. To simplify this, it is better that we convert these two delta networks to a star network. So let me write the equivalent resistances. So let the resistors be R1, R2 and R3. And here R4, R5 and R6. Now what is R1? So here we have a delta to a star conversion. So delta to a star conversion, the formulas are given here. So R1 is multiply these two resistances on either side of R1, which is 6 into 4 divided by the sum of resistors. 6 plus 4 plus 10 is 20. So that gives me 24 divided by 20, which gives me 1.2 ohms. So similarly, what about R2? So multiply these two resistances on either side. 6 into 10 is 60 divided by the sum of resistors is 20. So that gives me 3 ohms. So next let me find R3. So R3 is going to be multiply these two, which is 4 into 10, which is 40 divided by 20, which gives me 2 ohms. So R1, R2, R3, the values are given here. So next let us find R5. R5 is multiply these two, which is 20 into 10 gives me 200, divided by the sum of resistances, which is 20 plus 10. So R5 is 20 into 10, which is 200, divided by the sum of resistances 20 plus 10 plus 15, which gives me 45. So 200 by 45 gives me 4.44 ohms. Next R4. So R4 is multiply these two, 20 into 15. So 20 into 15 gives me 300 divided by 45, which gives me 6.67 ohms. And then R6. R6 is 10 into 15, which is 150 divided by 45, which gives me 3.33 ohms. Right? So now we don't have the delta network, but we have a star network. So now let me redraw the diagram. So I have 1.2 ohms, which is R1, and then R2, which is 3, and R3, which is 2 ohms. So now we have 6 and 9 on the other side. So I have 6 ohm resistor here, and then a 9 ohm resistor. And then I don't have this delta network, but I have a star network with R4, R5 and R6. So I have R4, which is 6.67 ohms, and then I have the other resistance, which is R5, which is 4.44 ohms, and then I have R6, which is 3.33 ohms. So this is A and this is B. Right? So now we need to find the equivalent resistance, which is very easy. Now we find that these three resistors are in series. That is 2 plus 6 plus 4.44. So I add up all of them. So that gives me 1.2 ohms. So this is 12.44. And then down we have these three resistors which are connected in series, so I add all of them up. So we get 18.67 ohms. and then we have 3.3 ohms between the two terminals A and B. Right? So now find the equivalent resistance. So these two resistors are in parallel. So finding the parallel resistance, so which is going to be 12.44 into 18.67 divided by 12.44 plus 18.67. So that approximately gives me 7.465. Right? Okay. So now to find the equivalent resistance across AB, so I add 1.2 plus 7.465 plus 3.33, which finally gives me 12 ohms approximately, right? So this is the equivalent resistance between the two terminals A and B, so it is 12 ohms. So this is how star delta transformation or delta star transformation will help us in simplifying the given circuit and find the equivalent resistance, right? So every textbook will have a number of problems dealing with star delta transformation and delta to star transformation. So make sure that you try to solve maximum problems so that it becomes much easier in the test or in your exams to do these transformations and simplify the given network, right? So the next video segment we will begin with network theorems. So we should begin with Thevenin's theorem, Norton's reciprocity, and all the other theorems. We will deal with all the network theorems one by one and take one or two examples and solve them. So I hope you have found this video lecture informative. Make sure that you do like, share and subscribe, and thanks for watching.